Good evening everyone, good evening. Welcome back to your JEE Enthuse. I hope you guys are doing great, having a good time. Well people, let me know in the chat box fast if I'm audible and visible to everyone. Yes. Let me know fast if I'm audible and visible to everyone. Give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you guys or not. Yes guys, do it fast. Hello Faisal, hello Ashwarya, hi Piyush, hi ABCD, hello Manisha, hello Sarvu, hi Umayal, hi Dharmendra, hello Palab, welcome, hi Priyanka, hi Tornado, hi Kasa, hello Saran. Welcome back everyone, welcome back to one more epic mock test number 13. Yes, is it going to be the 13th mock test? Yes, it's going to be the 13th one, right? So people, just fastly give me the green signal from the chat box so that I'll get to know whether I'm audible and visible to you guys or not. Then we'll be starting the session directly without wasting a lot of time. Yes? Yes, Suvarna, I'll be doing the rest part of the session which I did yesterday, right? The rest part of that session will be done day after tomorrow on Wednesday at 9 a.m. in the morning. Yes? So on Wednesday, there will be again one more 5-hour session in which rest of the chapters will be done, which we couldn't finish in the last session, yeah? Perfect. So people, as you all must be knowing, tonight it's going to be one more mock test. As I have told you, we'll be doing some 30 mock tests. And out of those 30 mock tests, it is going to be the 13th mock test, right? Okay, so before starting the session, the ones who are new to the channel, let me introduce myself. My name is Wassim Bhatt and I'm your chemistry master teacher writer on this JEE Enthuse channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends. Do not forget to subscribe to the channel as well. Do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking live on this JEE Enthuse channel. Yes? Right? Perfecto. So you can let me know in the chat box if you guys are super duper excited about the session so that we can start the session directly without wasting a lot of our time. Yes? Let me know in the chat box fast if you guys are super duper excited about the session, yeah? Let me know fast with some thumbs ups. Let me see the josh of the session, yeah? Exactly, mark your attendance by hitting the like, yes? That's perfect, Faisal, that's perfect. Yes, Arshad, absolutely, you're my regular student. I remember you properly. Yes? Perfect guys, so let's get started, let's get going with the rank booster JEE 2021 complete chemistry mock test 13 with the first question which is going to be on your screen in 3, 2, 1 and now. Very simple and basic question, directly your NTA question. Yes, I'm sure you guys are going to kill this one, right? No need to think about anything, just let me know the answer. It's a very simple and basic question guys, right? Okay. You'll be the luckiest ones if you get this type of a question in your mains examination, yeah? Right? Let me know its answer fast. Let me know its answer fast. Give it a try, let me know its answer fast. Well, Sudha is coming up with option D. Okay, Triniket, option D. Priyanka, 0. I didn't get what is the 0. ABCD is coming with option 4. Ashwarya is coming with option 4. I mean, everyone is coming with option 4. Yes? Okay, so people, it's a very simple and basic question, just the formula based, right? As you all must be knowing, orbital angular momentum of an electron is equal to under root of L into L plus 1 multiplied by H upon 2 pi. Yes, this is the relation to calculate the orbital angular momentum. What is this L over here? L is basically the azimuthal quantum number, right? And as you all must be knowing, right? For the s orbital, for the s subshell, the value of L is 0, right? For the p1, the value of L is 1. In case of D, we take the value of L as 2. And in case of F, we take the value of L as 3, right? And as per the question, the electron is present in 3s. I've got nothing to do with this 3. I need to see in which orbital electron is. Electron is present in s orbital where the value of L is 0. If the value of L is 0, this whole term becomes 0. So orbital angular momentum of an electron in any s orbital is going to be 0. Point number 1. Yes? So which option satisfies it? Option D satisfies it. So option D is the one which is correct among all. Yes? Right? I'm sure it's clear to everyone. So directly, let's get going. Let's get started with the next question, which is going to be on your screen in 3, 2, 1, and now. This is the question, a very simple and basic question, right? And I'm sure you guys can kill this one. Yes? Okay, let me know its answer fast. Let me know its answer fast, guys. Okay, what is obtained when chlorine is passed in boiling toluene and product is hydrolysis? Okay, so first I'm going to make the toluene to react with chlorine, and after that, whatever will be the product, that product is hydrolyzed. We need to see what is the final product which we'll be getting from here. Yes? What do you think about this? Is it going to be orthocresol? It's going to be paracresol? It's going to be 2,4-dihydroxytoluene? Is it going to be benzyl alcohol? What do you guys think? Just use your brain a bit. It's a very simpler one. It's a very simpler one. Give it a try. Let me know its answer fast, yeah? Let me know its answer fast. Absolutely, guys. Majority of you guys are perfectly correct. It's going to be option D. It's going to be benzyl alcohol, right? So basically what happens over here, I'm taking toluene. This is the toluene which I'm taking, right? Yes. What we are doing, what is obtained when chlorine is passed in boiling toluene. So this is the boiling toluene. I'm going to make it react with the chlorine. What is going to happen? What is that which I'll be getting from here? Yes, I'll be getting benzyl chloride. Yes, I'll be getting what? I'll be getting benzyl chloride. So simply just take one of the H out from here. Instead of that H, you guys can put chlorine over here. So what you'll be getting, first of all, you'll be getting something like this, which is going to be your CH2Cl, right? This is something which we call as benzyl chloride, right? Now people, this benzyl chloride is undergoing hydrolysis, right? And when this benzyl chloride will be undergoing hydrolysis, what you'll be doing is simply just remove this halogen. Instead of this halogen, place OH. That's it. Yes? I'm not giving you the mechanism or something. I'm just giving you the tricks to remember these questions, right? This is CH2OH, and this is something which we call as benzyl alcohol, right? So your benzyl alcohol is the final answer of this question. As per the question, what did we do basically? I took toluene, the boiling toluene, I made it to react with Cl2. We got something as benzyl chloride, and this benzyl chloride on hydrolysis, it's going to lead to the formation of benzyl alcohol, and final product is the benzyl alcohol, which is going to be your answer. Yes? So how many of you did it right? How many of you did this question on your own? Can you let me know in the chat box? Give me some thumbs ups in the chat box if you did this question on your own, right? Let me know fast. Yes, Arshad, the last marathon just ended after 5 hours, right? Because of some connectivity issues, right? So I'm going to continue that marathon day after tomorrow, Wednesday, at morning 9 a.m. sharp. That means on Wednesday, we'll be taking again 5-hour session in which I'll be completing the rest of the chapters. Till now, in that marathon session, we were done with solid state, solutions, electrochemistry, kinetics, surface, S block, P block, right? And GOC at the same time, yeah? So we were done with 8 chapters, yeah? The next marathon, that's going to be again 5 hours. So we'll be solving some 200 questions in that as well. Yes? Perfecto? Wonderful, guys. So majority of the students did it. Okay, let's move on to one more question. Yes? The number of sigma and pi bonds in naphthalene is. So you cannot solve this question unless you know the structure of naphthalene. Yes? You cannot solve this question unless you know the structure of naphthalene. Yeah? What do you think about this? Give it a try. Let me know its answer in the chat box. I'm looking at your chats only. And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Well, people are coming up with option C. Is that? Should I be believing on you? Oh, you guys are guessing it as option C, yeah? Right? Okay, so let's check it out. Let's check it out. From now onwards, remember the structure of naphthalene, okay? See, guys, how it's formed. It's a simple thing. Just make 2 rings like this. Just make 2 rings like this. First, put a double bond over here, right? Now put a double bond over here, put a double bond over here, right? Put a double bond over here, put a double bond over here, right? Okay. With every carbon, you have got hydrogen attached, right? Apart from these 2 carbons, rest all the other carbons, you have got hydrogen attached, like this. Yeah? Okay. This is the structure of naphthalene. This is the structure of naphthalene. Now check it out. How many sigma and how many pi bonds do we have? How many pi bonds do we have first of all? Yeah, how many pi bonds do we have? Okay, total how many sigma plus pi we have? Total sigma plus pi, when you'll be counting, it will be 24, right? Yes, it will be 24 in total. Sigma bonds plus pi bonds in case of naphthalene is going to be 24. Absolutely, guys, all of you are perfectly correct, right? Perfect. Exactly. It's 5 pi bonds and 19 sigma bonds, right? Absolutely, guys. Perfecto. So from now onwards, remember this structure. Remember this structure. Correct? Perfecto. Let's move on to one more question then. So we have got some 19 sigma and 5. Guys, do you know how to identify which one is pi and which one is sigma? Do you know that? Do you know that? Do you know how to check which one is pi and which one is sigma? Yeah? Don't give me the heart attack. Oh, perfect. Yeah. Okay. Perfect, guys. Let's move on then to one more question. All right. Oh my goodness, what did I just do? So you saw the answer. I'm really sorry about it. Yeah. So still, let's solve this question. We are given with P4O6 and P4O10, right? Very two important molecules these are, right? Remember their structures from now onwards. P4O6 and P4O10. First of all, let me make P4O6 and over here I'm making P4O10, right? See guys, first I'll be making 4 phosphorus atoms. I'll be drawing 4 phosphorus atoms right here. This is P4, right? Now join these phosphorus atoms by means of oxygen linkage. Yes, correct? So how many oxygens are there in total? 6. Out of 6 I have used 1, 2, 3 and 4, right? Now join this phosphorus and this phosphorus by means of a linkage like this. Join this phosphorus and this phosphorus by means of a linkage like this. So this is P4O6, right? This is P4O6. Now what about P4O10? Just replicate this P4O6 first. Just replicate this P4O6 first. Yeah, just make the replica of it. This is P4O6 first, yeah? Okay. Right, now, this is the phosphorus. Put one double bonded O. Put one double bonded O right here with one more phosphorus. Put one double bonded O and put one more double bonded O over here. This is P4O10. This is P4O6. Now what do we need to check basically? The number of oxygen atoms bonded to each phosphorus. Just check this phosphorus. How many oxygen atoms are bonded to this? 1, 2 and 3. Check any of the phosphorus over here. There will be 3 oxygen atoms bonded with this phosphorus, with any of the phosphorus in this P4O6. So there are 3 oxygen atoms bonded to any of the phosphorus in P4O6. Similarly, how many oxygen atoms are bonded to phosphorus in case of P4O10? Check it out. Check this phosphorus. 1, 2, 3, 4. Check this phosphorus. 1, 2, 3, 4. Sorry, 4. Check this phosphorus. 1, right? 1, 2, 3 and 4. So with every phosphorus, there are 4 oxygen atoms bonded. So what is going to be the answer of this question? 3, 4. So option C is the one which is correct among all, right? You can give me some thumbs ups in the chat box if you got it properly so that I can move on to the next one. Yes. Thank you, Gashvi. Thank you. Let me know in the chat box if you got it properly. People, I want you guys to remember the structures of these 2 molecules. These are really, really very important. And do not forget the structure of the naphthalene as well. Yeah? Perfecto. Let's then move on to one more question which is going to be on your screen now. This is the question, right? This is the question. When benzene or its derivative is treated with carbon monoxide and hydrogen chloride in presence of anhydrous aluminum chloride, it gives. People, there is a special name for these kind of reactions, right? There is a special name for these kind of reactions. Do you guys remember that? Do you guys remember that? There is a special name for these kind of reactions. Exactly, Parati. These are called as Guttam and Gotch reactions. Yes, this is called as Guttam and Gotch reaction. And in case of your Guttam and Gotch reaction, you get benzaldehyde as the product. Yes, remember it in short. In case of your Guttam and Gotch reaction, you get benzaldehyde as the product. Whenever you'll be taking the benzene or its derivative, you'll be making it to react with carbon monoxide and hydrogen chloride in presence of anhydrous aluminum chloride. What you'll be getting at the end? You'll be getting benzyl, right? You'll be getting benzaldehyde as the product. So it's going to be option A directly. No need to remember anything else. Just remember this, okay? In case of Guttam and Gotch reaction, you'll be getting benzaldehyde as the product. That's it. Yeah, that's it. One more on your screen from the chapter Thermodynamics. Okay, this question was once asked in your JEE examination. I think this was asked in advanced, right? Okay, yeah. This question is a simpler one, but there's a high probability of you guys to make a mistake in this one. Yeah? Okay, give it a try. Let me know its answer. Archid, you check the Telegram group. In the Telegram group, it was updated today itself. Yeah? Well, people are coming up with option C. Some are saying option B. Some are saying 4. Give it a try properly. Give it a try properly. I'm waiting for you. Okay, so let's see how this question is to be solved. Understand properly. First of all, 1 mole of non-ideal gas. So basically, I have got a real gas with me, right? I've got a real gas with me. Well, ELK gallery, you can click on the link which is there in the description box of the video. After clicking on the link which is there in the description box of this video which you are watching currently, okay, you'll be getting a link. Just click on that. You'll be directed to the crash course. Okay, let's see how this question is to be solved now. Now, first of all, I'm given with 1 mole of a real gas, which is the non-ideal, yes? It undergoes the change in the state from 2 atm, 3 liters, 100 Kelvin. So when the real gas is present at the initial state, its pressure is 2 atm, its volume is 3 liters, and at the same time, its temperature is 100 Kelvin, right? So I'm saying the gas is currently at state 1. This is the initial state of the gas. Now we are going to change the state of the gas. How do we change the state of the gas? These are something which I call as state parameters, right? If you want to change the state of the gas, you're supposed to change the value of any one of the state parameter. If you just change the value of any one of the state parameter, the state of the system will automatically get changed, right? See, I'm changing the state parameters. I'm changing the pressure from 2 atm to 4 atm. Yes, I'm changing the volume from 3 liters to 5 liters. I'm changing the temperature from 100 Kelvin to 250 Kelvin, right? I'm calling this state of the gas as the final state. This is the final state of the gas, right? People, there's a general relation between delta H and delta U. There's a general relation between delta H and delta U. Delta H is equal to delta U plus delta of PV. This is valid for ideal gases as well as real gases. This is valid for all type of gases. Yes? Now you need to check. Is the pressure of the gas changing? Absolutely. Is the volume of the gas changing? Absolutely. Pressure is changing, volume is changing. So I can convert this relation like this. Delta H is equal to delta U plus, I'll be writing it as P2V2 minus P1V1. As simple as that, yeah? So delta H, I'm supposed to calculate, is equal. What is the value of delta U? Delta U is given to me as 30 liter atm. I'm writing the units as well so that there won't be any sort of doubt. P2V2. This is the value of final pressure. This is the value of final volume. So 5 multiplied by 4. P2 multiplied by V2. 5 4s are 20. Minus P1 multiplied by V1. P1 multiplied by V1. 3 2s are 6. Right? So the final value. Okay. The units of this term. The units of this term. Since it is P multiplied by V, it's again going to be atm liter only. Right? So when you solve this, 30 plus 14, it will come out to be what? It will come out to be 44 liter atm. Correct? So this is the value of delta H which we are supposed to calculate. Right? This is the value of delta H which we were supposed to calculate. It's going to be option 2, right? Now people, one more thing. If you were not supposed to calculate it into liter atm, if you were supposed to calculate this in joules, remember 1 atm liter is equal to 101.3 joules, okay? This is the value of delta H which you got in liter atm, right? In order to convert it into joules, you are supposed to multiply this by 101.3. You'll get the answer in joules as well, yeah? Remember this. Perfect? Wonderful. Moving on to one more question then. Okay. Rank the following carbocations in the order of the stability. Yes. Rank the following carbocations in the order of the stability. I want answers from everyone this time. Yeah. These are the carbocations which are given to me. You need to arrange these carbocations on the basis of stability. People, all of you must be knowing 3 degree carbocations are more stable than 2 degree carbocations, then 1 degree carbocations, then 0 degree carbocations. That's something which you all must be knowing. Yes, that's something which you all must be knowing. Yeah. So what do you think about this one? Are you guys going to use the same concept? Guys, apart from all this, you need to exactly see which carbocation is resonance stabilized. Which carbocation is resonance stabilized. If there is any carbocation that is resonance stabilized, that's going to be the highest stable. That's going to be the highest stable, right? If, for example, there is a 3-degree carbocation, and at the same time, I've got a 2-degree carbocation, and this 2-degree carbocation is, for example, resonance stabilized as well, then you, at that time, your 2-degree is going to be more stable than 3-degree, right? Remember this thing. Now check it out. Is this 3-degree carbocation over here? Yes, this is 3-degree carbocation. Is this one the 3-degree or 2-degree? This is 2-degree carbocation. What about this one? This again 3-degree carbocation. This again 2-degree carbocation, right? Yes. So we have got 2 3-degree carbocations, 2 2-degree carbocations. Yeah. Now check which one is resonance stabilized. Which one is resonance stabilized? Check it out. This positive charge is simultaneously in conjugation with this pi bond as well as this pi bond, right? Can I say over here positive charge is in conjugation? So we have got, I'll say this positive charge is resonance stabilized. It is resonance stabilized. So no doubt it was 3-degree, but at the same time it's resonance stabilized. Yeah. Now what about this one? What about this one? This positive charge is again resonance stabilized. Positive charge sigma pi. Sigma pi. This positive charge is again resonance stabilized. This is again resonance stabilized. Is this one resonance stabilized? No way. Is this one? No way, right? Now people are, check one more thing. This in over here, no doubt this positive charge is resonance stabilized. But can I say this positive charge is simultaneously in conjugation with this one as well as with this one? So is this the case of cross conjugation? This is the case of cross conjugation. What about this one? This is the case of linear conjugation. This is the case of extended conjugation right here. You can see this is the case of extended conjugation, right? Okay. I hope you know this. This is the case of extended conjugation. And extent of resonance in extended conjugation, in linear conjugation, is more than that of cross conjugation. And wherever extent of resonance is more, there only stability will be more. So which one is maximum stable among all? What do you think? Which one is maximum stable among all? I'll say B is maximum stable among all. Then over here resonance is there, but extent of resonance is a bit less than that of B. Then comes your A, right? Now among these two, this is 3-degree, this is 2-degree. So C is going to be more stable. Then at the end we have got D. So this is going to be the order B, A, C, D. Is there any option like that? B, A. Just give me a second. Yeah, B, A. Just a second, guys. B, A, C, D. Okay, it's going to be option 1 only. Yeah, yeah, it's going to be option 1 only. Happy home will be doing that. No issues. Yes. Perfecto. Wonderful, guys. Great job done. So this question you did on your own. How many of you did this question on your own? Can you let me know in the chat box fast? I just want to see exactly. Perfect, guys. Wonderful. Good job. Okay, let's move on to one more question then. This is one more question from the chapter. Which question is this? This is the titration question. Okay, this is from the redox. This question is from the redox. Give it a try. Let me know fast. It's a very simple question, guys. Trust me, it's a very simple question. Just remember one thing. Just remember one thing. Just remember one thing. There are few formulas by means of which you can calculate the number of gram equivalents. The number of gram equivalents. There are few formulas for that. One is going to be normality multiplied by volume. One is going to be mass of solute divided by equivalent mass multiplied by not multiplied by anything, because we are talking about number of gram equivalents. Mass of substance divided by equivalent mass of substance. There is one more formula, number of moles of the substance multiplied by n factor of the substance. These are certain formulas. These are 3 formulas by means of which we can calculate number of gram equivalents. Now similarly, if I need to calculate the number of milli equivalents, I'm just giving you the formulas first, yeah? Number of milli equivalents is going to be equal to normality multiplied by volume in milliliters. Right here, it's normality multiplied by volume in liters, which is also equal to given mass of the substance divided by equivalent mass of the substance multiplied by 1000, right? Which is also equal to, instead of moles, I'll be writing number of millimoles. Number of millimoles of the substance multiplied by n factor of the substance, yeah? Okay, so these are few formulas which I want all of you to take a note of. Now, how am I going to approach this sort of equation? Understand. 0.1 molar KMnO4, right? So let me call this KMnO4 as 1. Let me call this S2O3 dinegative as 2. So I'm given with the molarity of KMnO4, right? This is, for example, KMnO4 1. This is, for example, S2O3 dinegative 2, right? I'm given with the molarity of KMnO4, which I'm representing by M1, that is 0.1. Yes. is used to the following titration. What volume of the solution in ml? I need to calculate the volume of KMnO4 in milliliters. What volume of the solution in ml will be required to react with 0.158 grams? To react with 0.158 grams of what? Of Na2S2O3, whose molar mass is this much. Okay. That's something which we need to calculate, right? First thing which I'll be doing. Let me calculate the n factor of first. Let me calculate the n factor of second. Yes, n factor of first means n factor of MnO4 negative. See, what is the oxidation state of Mn right here? It's +7, right? This MnO4 negative, it's changing into MnO2. What is the oxidation state of Mn over here? It's +4. +7 to +4. +7 to +4. Oxidation state is decreasing. Decrease in the oxidation state is what we call as reduction, right? Yes, and that reduction means gain of electrons. So +7 to +4, how many electrons are being gained by this MnO4 negative? 3 electrons are being gained by this MnO4 negative. So I'll say its n factor is 3, right? I'll say its n factor is 3. Or you can simply check it out like this. Just calculate the change in oxygen state. Final oxygen state minus initial oxygen state, right? Okay, n factor of 1 is 3. Now what about the n factor of 2? What about the n factor of this substance? Have a look. First thing, calculate the oxidation state of sulfur over here. Let's assume the oxidation state of sulfur is x. So it's going to be 2x minus 6 is equal to -2. So x value you'll be getting as +2, right? Okay, x value you got as +2. So oxidation state of sulfur over here is +2. And this S2O3 dinegative, it's getting converted into SO4 dinegative, where the oxidation state of sulfur is +6. Check it out. +2 to +6. What is the change in the oxidation state? 4 is the change in the oxidation state. +2 to +6. 4 is the change in the oxidation state. But that 4 is the change in the oxidation state for 1 atom of sulfur. How many atoms of sulfur we have? 2. So 4 multiplied by 2 is 8. So 8 is basically the n factor of this substance. 8 is basically n factor of this substance. I got to know n factors of both. Why am I doing it? I just want to use the equivalent concept. I just want to equate the gram equivalence of these two substances, or I just want to equate the milli equivalence of these two substances. That's all what I want. Yes? I can say something like this. Now I can say milli equivalence of 1 should be equal to milli equivalence of 2 as per the equivalent concept is concerned, right? Milli equivalence of 1. Milli equivalence of 1 is going to be normality of 1 multiplied by volume of first in milliliters, right? I can write it like this. Milli equivalence of second, I can write mass of second divided by what? Divided by equivalent mass of second multiplied with 1000, right? I can write this equation. Yeah. Now how solving this equation will get the answer? Have a look. I know the molarity of first, I know the molarity of KMnO4, I know its n factor. Molarity multiplied by n factor gives you the normality. Molarity multiplied by n factor gives you the normality. So normality of first, normality of KMnO4 is going to be 0.1 multiplied by 3. That means 0.3 multiplied by V1 we are supposed to calculate in milliliters. W2, mass of second, that's given to me as 0.158 divided by equivalent mass of second. Equivalent mass of second. Equivalent mass of second means molar mass of second divided by n factor of second, right? Molar mass of second means molar mass of S2O3 dinegative. Molar mass of this substance is 158 divided by n factor we got to know as 8. So this is basically the equivalent mass of the substance, which is 158 divided by 8. I'm writing it as 158 divided by 8, correct? Multiplied with 1000. Can I say I got one equation in which there is only one variable? In which only there is one variable, that's V1. So can we calculate V1 from here? Yes, that V1 is something which we were supposed to calculate, right? That V1 is something which we were supposed to calculate. And V1 value comes out to be exactly 26.7. I just equated the milli equivalence of both, right? And at the end, I got the V1 value, I got the volume of KMnO4 which is used in this reaction, which comes out to be 26.7, right? Let me know fast if it is clear to everyone. And people, if you have not liked the video, please do like the video, share the video with your friends at the same time so that they get benefit out of these sessions as well. Yeah? Perfecto. Let's move on to one more question. Yeah? This is one more question. Which of the following has the highest Ka value? Ka value means more the Ka value, more the acidic strength, right? Basically, you are going to check which one has got the highest acidic strength. Yeah? Which one has got the highest acidic strength? What do you think about this question? First of all, you need to see the acidic site. Which one is the acidic site? Which site is common to everyone? This site over here, same site over here, same site over here, same site over here. So I selected my reference. We know acidic strength is directly proportional to minus effects. Acidic strength is directly proportional to minus effects. Over here we have got fluorine, fluorine everywhere we have got fluorine, and fluorine it shows minus I, right? Fluorine it shows minus I. And people, you all must be knowing, inductive effect, it is distance dependent. Wherever distance is more, inductive effect is less, right? So I'll say the distance is maximum in this case, yeah? So minus I power of fluorine will be least in this case, okay? So if minus I power of fluorine is least in this case, so this is going to be the least acidic. That means which one is more acidic? That means which one is more acidic? Which one is more acidic? I'll say fourth one is more acidic. By the way, your 3 and 2, these are same options, right? 3 and 2, these are same options. So option 4 is the one which is going to be the correct one. Reason? Because fluorine is closest to this site in this molecule, right? So wherever fluorine will be closest, there minus I effect of fluorine will be more dominating. If minus I effect of fluorine is more dominating right now, so this hydrogen will be leaving out easily, okay? Right? So this is going to be the maximum acidic right here. Okay? Perfect. Let's move on to one more question then. This is one more question on your screen. This is something which is very simple. I'm sure you guys can kill this one. Let me know its answer fast. Let me know its answer fast, guys. Fast. I want every one of you to say it now. Let me know its answer fast. Exactly, Harshita. More Ka, more acidic. Well, people are coming up with option B. Is that? Guys, it's not a memory-based question. It's not a memory-based question. It's not a memory-based question. KP Singh, this is the English channel, bro. That's why I'm not talking Hindi. Otherwise, मैं हिंदी में ही बात करता हूँ. चलिए, let's move on. See, we are given with two things. The first ionization energy of magnesium and aluminium. So I'm given with magnesium, and at the same time I'm given with aluminium. Magnesium and aluminium, they belong to same period, right? And as we move along the period, what happens to ionization energy? Ionization energy increases. So what is the expected order of ionization energy? This is the expected order of ionization energy, but actually it's opposite of it. The actual order is opposite. Magnesium has got more first ionization energy than that of aluminium. What is the reason for that? What is the reason for that? In case of magnesium, its outermost configuration is 3s2. Aluminium has got the outermost configuration of 3p1. So in magnesium, if you want to take the electron out, you have to take the electron out from the stable configuration. Over here, it's not the stable configuration, right? So wherever there is stable configuration, from the stable configuration, you have to supply more energy to knock the electron out. That's why magnesium has got more first ionization energy than that of aluminium. So magnesium has got more. First one is for magnesium, second one is for aluminium. So magnesium will be having more ionization energy than that of aluminium. There is only one option which says magnesium has got more ionization energy than that of aluminium, right? Okay, so option 1 is the one which is correct among all. Yeah? Correct? Exactly, guys. No need to remember the values, yeah? Just use your brain a bit, that's it. The question is done and dusted. Perfecto. Let's move on directly to one more question then, yeah? Let's move on directly to one more question. This is one more question. Okay. Which one of the following reagents may not be used to convert alkyl chlorides and alkyl bromides into alkyl fluorides? What do you think? What do you think? What do you think, guys? What do you think? What do you think about this? See, first thing, your alkyl chlorides as well as alkyl bromides, they can be converted into alkyl fluorides. If you use the reagent as Hg2F2, absolutely. If you use this reagent, you can convert your alkyl chlorides or alkyl bromides into alkyl fluorides. Or if you use this reagent, this can be also done, right? If you use this reagent, this can be also done. But if you are using this reagent, the reaction is not going to happen. On using this reagent, you cannot convert your alkyl bromides as well as alkyl chlorides into alkyl fluorides. Option D, Schwarz reaction, guys, Schwarz reaction. I hope you remember that, Schwarz reaction. Yes? Right? Exactly, Jerry, you're right. It's going to be the Schwarz reaction. Perfect? So if you want to convert your alkyl chlorides or alkyl bromides into alkyl fluorides, you can use this reagent, you can use this reagent, you can use this one, but you cannot use CaF2. Yeah? Okay? Perfecto. Moving on to one more. The question says, the solution containing 10 grams of a non-volatile non-electrolyte and 4 grams of water boils at 100.256 degrees centigrade at 1 atm. molecular weight of solute is? A very simple and basic question. Yeah, based on the elevation of boiling point. Since we are using the non-electrolyte, so its Van't Hoff factor is 1. So I'll be using the formula delta TB, elevation in boiling point, is equal to Kb multiplied by molality. Molality is mass of solute multiplied by 1000 divided by molar mass of solute multiplied by mass of solvent in grams, right? This term is in grams, even this term is in grams as well, right? First of all, it's mentioned to me, I'm using 10 grams of non-volatile solute in 400 grams of water. So which one is in excess? Water is in excess, so water is my solvent. Water is my solvent, yeah? So mass of solvent is given to me, W1 value is given to me as 400 grams. Even mass of solute is given to me as well, that's 10 grams, right? Now people, we are keeping the pressure as 1 atm. 1 atm means 760 ml of Hg, right? Yes? Okay? Right? So first thing, delta TB, elevation in boiling point. Elevation in boiling point means boiling point of solution minus boiling point of solvent. What is the solvent? Water. What is the boiling point of water? 0 degrees centigrade, right? So I'll be writing delta TB, which is basically the boiling point of solution minus boiling point of solvent is equal to Kb value is given to me as 0.512, W2 is given to me as 10, sorry, I wrote 40. W2 is given to me as 10 multiplied by 1000 divided by molar mass of solute. I think this is something which I need to calculate, right? M2 is supposed to calculate. W1 is given to me as 400, correct? Boiling point of solvent, which is water, that is 0, correct? And boiling point of the solution is also given to me as 100.256 degrees centigrade, right? So you got one equation in which you just have one variable. And what is that variable? That's M2. So from here, can't you get the value of M2? From here, can't you get the value of M2? Yes? Right? You can get the value of M2. And what is the exact value of M2 which you'll be getting? Exact value of M2 you'll be getting as 50 grams per mole. Right? M2, molar mass of solute, right? What did I write? Did I write the boiling point of water as 0 degrees centigrade? Is that? Guys, that's understood, right? Boiling point of water is 100 degrees centigrade, right? Okay, that's understood. I thought that's freezing point. Okay, perfect. My bad. Yeah? Okay, perfecto. Let's move on to one more question then. Let's move on to one more question. The correct order of decreasing S character in the hybrid orbitals of the given molecules is, we are given certain molecules, we are going to arrange them on the basis of their decreasing S character. What do you think about this question? Give it a try, let me know fast. Give it a try, let me know fast. Give it a try, let me know fast. You need to arrange them on the basis of order of S character. So for that, you should know the hybridizations involved in all these. If I talk about NO3 negative, in case of NO3 negative, what is the hybridization? NO3 negative, what is the hybridization? Can you let me know fast? What is the hybridization involved in NO3 negative? Guys, do you know it? It's sp2. What is the hybridization involved in BRF5? 5 sigma bonds, 1 lone pair. 5 plus 1, 6. It's going to be sp3d2. XeO3, 3 sigma bonds, 1 lone pair. 3 plus 1, 4, right? It's sp3. Yeah, I3 negative, sp3d. Yes, BF2, sp, correct? Right? You got the hybridization of each. You got the hybridization of each. Now calculate the S character. S character in case of the first one is going to be S means 1 and how many orbitals have participated in the intermixing? 1s and 2p. So 1 divided by 3 multiplied by 100, right? So 33% S character. Similarly, 1 divided by 3 to 516. 1 divided by 6 multiplied by 100, right? This is the percentage S character over here. Similarly, sp3. 1 divided by 3 plus 1, 4 multiplied by 100. This is the S character right here. Similarly, I3 negative. S is 1, so this is 1 plus 3 plus 1. 1 plus 3, 4 plus 1, 5. 1 divided by 5 multiplied by 100. This will give the percentage S character. Similarly, SP. Over here, it's directly going to be 50%, right? Now, you are going to arrange these S characters on the basis of increasing order. The question is done and dusted, right? Yeah? You got the S characters of everyone, right? You can solve them up, yeah? You can solve them up and then arrange on the basis of increasing order of the S character, right? So, people, what is going to be the correct answer of this one? Correct answer is going to be the last one, right? This is option 4 is the one which is correct. Absolutely, you all are perfectly correct. It's going to be option D, right? Perfecto. Let's move on to one more question then. Okay, for the reaction, 3 times A gives C plus 2D. Initially, A was taken. The equilibrium concentration of D is twice that of A. Okay, the value of Kc is again a very simple question. Again, a very simple question. See how this is to be solved. Let me write the reaction first. 3 times A in equilibrium with C plus 2D. Yeah, 3 times A in equilibrium with C plus 2D. At time t is equal to 0, let's assume concentration of this A is C, this is going to be 0, this is going to be 0, right? Now I'm going to treat this concentration in the same way as that of moles. The way I used to treat moles in equilibrium, in the same way I'm going to treat the concentration, right? So at equilibrium, let's assume it's going to be C minus X, right? Now see, 3 moles are giving me 1 mole. So 1 mole of A gives 1 by 3 moles of C, right? So X moles should give X by 3 moles of C, right? Similarly, 3 moles of A gives 2 moles of D. 1 mole of A gives 2 by 3 moles of D. So X moles are going to give me 2 by 3 multiplied by X moles of D, right? And it's mentioned in the question. The concentration of D at equilibrium is equaled twice that of A, 2 times the concentration of A at equilibrium, right? What is the concentration of D at equilibrium? This is the concentration of D at equilibrium, 2 divided by 3x is equal to 2 times. What is the concentration of A at equilibrium? This is the concentration of A at equilibrium, which is C minus X. Can we solve this a bit? Yeah? Right? We can solve this a bit. Perfect. So it's going to be 2 divided by 3x is equal to 2 times C minus 2x. So from here, you can get the value of x, right? So it's going to be 2 divided by 3x plus 2x is equal to 2c, correct? It's going to be 3 2s are 6, 6 to 8. So it's going to be 8x divided by 3 is equal to 2 times c. From here, get the value of x. X is going to be 3 2s are 6c divided by 8, or you can write it as 3 divided by 4c, correct? So you got the value of x. You got the value of x. X is 3 by 4c. You got the value of x. So what is the concentration of A at equilibrium then? That's C minus X. X value you already got to know, that's 3 by 4C, correct? So C minus 3 by 4C comes out to be 1 by 3C. So this is actually the concentration of A at equilibrium. Similarly, X by 3. X value we got to know is 3 divided by 4 multiplied by C, and in the denominator there's already 3. 3 got cancelled, it becomes C by 4, right? C by 4 is the concentration of C at equilibrium, correct? Similarly, it's going to be 2 divided by 3 multiplied by X. X is 3 divided by 4 multiplied by C. 3 got cancelled, so it's going to be C by 2. So C by 2 is the concentration of D at equilibrium. So I got the concentration of each species at equilibrium, right? Yes, I got the concentration of each species at equilibrium, right? This is 1 by 4C, correct? I got the concentration of each species at equilibrium. Yeah? I got the concentration of each species at equilibrium. What do I need to do now? I'll be simply writing the expression for Kc, yeah? So Kc expression is going to be what? Concentration of C at equilibrium raised power stoichiometric coefficient, that's 1, multiplied by concentration of D at equilibrium raised power stoichiometric coefficient 2, divided by concentration of A at equilibrium raised power stoichiometric coefficient 3. I got all the values. Put these values into this equation, you'll be getting the value of equilibrium constant, yeah? So what is the final result you are getting? Have a look. Finally, you are getting the Kc value as 4. After putting all these values into this expression, you are getting the Kc value as 4, and which is going to be option A, yeah? Right? Guys, is it clear to everyone? Should I be moving on to the next one? Should I be moving on to the next one? Simple question this is, right? Perfect, guys. Wonderful. Let's move on directly to one more question then. Okay. The osmotic pressure of equimolar solutions of urea, BaCl to AlCl3 will be in the order of. Okay. So we are given with the solution of urea. We have got solution of urea. We have got solution of BaCl2, and at the same time we have got solution of AlCl3. All the ones are equimolar. Molarity of all these solutions is same. What do I need to do? I need to arrange them on the basis of osmotic pressure. Osmotic pressure pi is directly proportional to Van 't Hoff vector, right? Or you can say osmotic pressure is directly proportional to number of particles which will be getting from one particle of urea, or one particle of this, or one particle of this, right? Okay. N stands for number of ions basically, which we get. For urea, you can say Van 't Hoff vector is 1. Over here, this BaCl2, it would have got dissociated as Ba di positive plus 2 times Cl negative, correct? So one particle of this BaCl2 gives 1 plus 2, 3 particles. So N value is 3 for this. What is the N value? N value is 4 for this, right? So wherever N value is maximum, there only osmotic pressure is maximum. So osmotic pressure will be maximum in AlCl3 followed by BaCl2 followed by urea, right? Okay. Yeah. Urea is a non-electrolyte. Its Van 't Hoff factor is 1, right? It's a non-electrolyte. For the non-electrolytes, Van 't Hoff factor is taken to be 1. Yeah? Perfecto. Wonderful. Got the unpaired electrons. Over here, there's a weak field ligand, right? NH3 is a weak field ligand, so no pairing will happen. This nickel has got the +2 oxygen state, so the configuration will be 3d8, right? 3d8, 4 is 0. So hybridization will be sp3d2 because it has to arrange some 6 empty atomic orbitals for hybridization for intermixing. Yeah? Okay, so it's definitely going to have what? Unpaired electrons, 2 unpaired electrons it will have. Right? I'm sure it's clear to everyone. Let's move on to this one now. Let's move on to the next question. Now we have got electron, we have got alpha particle, we have got a proton, right? I need to arrange them on the basis of what? On the basis of energies. E1, E2, E3 relation I need to calculate. First of all, how do we calculate kinetic energy? Kinetic energy is nothing. It is equal to half of mv square, right? What is de Broglie's wavelength all about? Lambda is equal to h upon mv. So from here, can I calculate v? V is going to be h upon m multiplied by lambda. Now put this v into this equation. Can I say kinetic energy is basically equal to half of m v square. V square is simply going to be h square divided by m square multiplied by lambda square, right? Square and m got cancelled out. So you got kinetic energy of the species is going to be half of h square divided by m square multiplied by lambda square. Now it's mentioned in the question that all these particles right here, they have got same wavelength. They have got same de Broglie's wavelength. So can I say this square, it has got cancelled, though this is basically m raised power 1. This square and this m got cancelled, right? So you got to know kinetic energy is basically inversely proportional to m, right? Now use this parameter, kill the question. Kinetic energy is inversely proportional to m right now because all the three particles right here have got the same de Broglie's wavelength, yeah? So wherever mass is less, there only kinetic energy will be more, right? Which has got the least mass among all? Electron has got the least mass, right? What is the kinetic energy of electron? Yes, E1. So E1 is going to be maximum. E1 is going to be maximum. Then comes your proton. It's going to have E3 energy. Then comes your alpha particle. Is the heaviest among all. Then comes your E2. So E1, E3, E2 is going to be the order. It's going to be option 1, which is correct among all, yeah? Right? Irfan, it's a weak field again. Okay, moving on to one more. Let's move on to one more question. Okay, we have got one more question. The coagulation value of the electrolytes used for coagulation of AS2S3 are given. The correct order of their coagulation is. Basically, you should mention the question as the correct order of their coagulation power is. Okay, now let me know the answer of this question. Let me know the answer of this question. Yes? Are you... Let me know the answer of this question fast. Gaurav, I'll be coming soon because it is the high time for JEE 2021 people to have the good mock test. That's why we have stopped for some days the class 11 series. Yeah. People, it's simple. Remember, coagulation value is inversely proportional to coagulation power, right? I'm given with the coagulation values of all. Which has got the least coagulation value? This one has got the least coagulation value, so maximum coagulation power. So this one will have, third will have maximum coagulation power, right? Third one will have maximum coagulation power, then comes your first, then comes your second, right? So 3, 1, 2 is going to be the order. Now check it out, 3, 1, 2, 3, 1, 2, yes, option 1. Done and dusted, right? Right? Oh, it is 0.69, sorry, I thought it's 69, okay. So it's going to be 3, 2, 1 then, yeah? It's going to be 3, 2, 1. 3, 2, 1 is the order of the question. So it's going to be 3, 2, 1. Option 4. Yes. Perfect. Minus 18 joules per atom, right? Okay. The energy of the first stationary state N is equal to 1 of Li di positive. Per atom is. This is the question which is given to me, right? Just a second. This is the question that's given to me. Now people, first of all, you all must be remembering the formula. Ionization energy is calculated by the formula 13.6 Z square divided by N square, electron volts per atom. I hope you remember this, right? So can I say something like this? First of all, He positive. What is the value of Z of helium? Atomic number of helium, that's 2. Yeah. What is the N1? Ionization energy, He positive, single electron species. That electron will be in shell number 1. So N1 value is equal to 1 basically in case of He positive. Lithium, Z2 is equal to 3, right? What is the N2 value? N2 value. First stationary state of Li, di positive. That means N2 is equal to 1, right? So can I write something like this? Ionization energy 1 divided by ionization energy 2 will be equal. Ionization energy 1 divided by ionization energy 2 is equal to Z1 square divided by Z2 square, right? Multiplied by N2 square divided by N1 square, right? The question is done and dusted. The question is done and dusted, right? Okay. I'm given with the first ionization energy, but it's in joules per atom, right? I'm given the first ionization energy in joules per atom. So you can calculate IE2 because Z1 is given to us, N2 is given to us, Z2 is given to us, N1 is given to us. So you can get the value of ionization energy 2 over here, right? Isn't it simple? Isn't it simple? Yeah. So people, this is something which I did, as simple as that. This is something which I did, correct? Because N1 as well as N2, that's given as 1, right? So finally, you are getting the answer as 4.41 into 10 raised power minus 17 joules per atom. What was I supposed to calculate? The energy of the first stationary state. So I got the ionization energy of Li di positive, and remember ionization energy of Li di positive will be equal to minus times the energy of electron in the first energy state of Li di positive, correct? Yes? Okay, what I'm writing over here, what I'm telling you over here, ionization energy of the single electron species is always equal to the energy of the electron in the same single electron species in shell number 1 with the minus sign. Remember this. Okay, since you got the ionization energy of Li di positive, that means you can calculate the energy of the electron in the first energy state, which is going to be minus times of this, right? Yes? I'm sure you got it perfectly. Let's move on to one more question then. In the reaction 4A plus 2B plus 3C gives A4B2C3, what will be the number of moles of products formed starting from 1 mole of A, 0.6 moles of B and 0.72 moles of C? Again, a simple question, guys. See, the reaction that's given to me is 4 times A plus 2 times B plus 3 times C, right? It gives what? It gives A4B2C3. I'm starting with at time t is equal to 0. How many moles of A do we have? We have got some 1 mole of A. How many moles of B we have? We have got some 0.6 moles of B. How many moles of C we have? We have got some 0.72 moles of C. This will be 0 at time t is equal to 0. Yes? Right? Right? Now people, 1, 0.6, 0.72. If you look at the equation, I'm given with the amounts of all the reactants. So which concept will I be using? I'll be using the concept of limiting reagent, right? Now it is the time to identify the limiting reagent. How do we identify it? Divide the given moles by the stoichiometric coefficient 1 by 4, 0.6 divided by 2, 0.72 divided by 3. Which value comes the least? Which value comes out to be the least? Right? It is 4A plus 2B plus 3 times C. 1 mole of this, 0.6 moles of this and 0.72 moles of C. Right? I divided each by the stoichiometric coefficient. Right? So which value is going to be the least? 1 divided by 4 is 0.25. This is 0.3, this is 0.24, so this is the least value. So C is my limiting reagent. Yes, C is my limiting reagent. If C is the limiting reagent, after some time there will be 0 moles of C left, right? Now C is going to decide how many moles of this product will be getting formed. Have a look. 3 moles gives 1 mole, 1 mole gives 1 by 3, so 0.72 gives 1 by 3 multiplied by 0.72. The value will come out to be how much? The value will come out to be 0.24. So 0.24 moles of the product have got formed. Entire product is basically decided by the limiting reagent, right? Yes? I'm sure it's clear to everyone. Yeah? Moving on to one more question. Okay, this is one more question from the chapter Chemical Kinetics. I'm sure you can solve this easily. At 500 Kelvin, the half-life of the gaseous reaction at the initial pressure of 80 kilopascals is 350 seconds. When the pressure is 40 kilopascal, the half-life period is 175 seconds. The order of the reaction is, for example, this is the reaction, A gives B. I'm assuming the order of this reaction is N. I'm assuming the order of the reaction is N, right? When the pressure of A is 80 kilopascal, at that time, when the pressure of A When the initial pressure of A is 80 kilopascal, at that time the half-life of this reaction is given to me as how much? Is given to me as 350 seconds, right? Now I'm changing the pressure. I'm changing the pressure of reactant. I'm changing the pressure of reactant from 80 to 40. When the pressure of reactant is 40, at that time, when the initial pressure of reactant is 40 kilopascal, at that time half-life of the reaction is how much? It is 175 seconds. I need to check the order of the reaction. How do I check it? Simple. Remember, half-life of the reaction is directly proportional to initial concentration of reactant or initial pressure of reactant raised power 1 minus n, where n is the order. So I can say half-life at pressure P1, let's call this as P1, let's call this as P1 and P2 respectively, yeah, so that it'll be clear to you. Half-life at pressure P1 divided by half-life at pressure P2 is going to be equal to what? It's going to be equal to P1 divided by P2 raised to the power 1 minus n. General result, yeah? General result. What is the half-life at P1? Half-life at P1 is 350. Half-life at P2 is 175, right? Is equal to P1 by P2. P1 is 80, 80 by 40 is 2. So 2 raised power 1 minus n, correct? So this is going to be 1, this is going to be 2. So 2 raised power 1 minus n is equal to 2 raised power 1, correct? When is that possible? When 1 minus n is 1. So from here, n value is 0. What is n? N was the order of the reaction. So you got to know the order of the reaction is 0, yeah? Exactly, it's a 0 order reaction. Remember this formula, guys. Half-life of the reaction is directly proportional to initial concentration or initial pressure raised power 1 minus n. That's it, right? From here, like this, you can solve these sort of questions, right? Let's see if we have more questions or not. Yes, we have got one more question. Have a look. pKa of weak acid. I'm given with the pKa of weak acid. It's given to me as 5.76, right? And pKb of weak base, it's given to me as how much? It's given to me as 5.25. A very simple basic equation. What will be the pH of the salt found with it too? So first of all, I'm making weak acid to react with weak base. I'll be getting a salt of weak acid and weak base. Now basically I'm doing the hydrolysis of salt of weak acid and weak base. How do we calculate its pH? There's a general result for it, if you remember. pH is equal to 7 plus half of P of Ka minus P of Kb, right? It's going to be 7 plus half of. What is P of Ka? 5.76. What is P of Kb? 5.25. Just solve it. That's going to be your answer, yeah? Right? Exactly, guys. Solve it, get the answer. People are saying it's 7.255. Let me check it out. Exactly, it's 7.255. As simple as that, right? Yes? Perfect. This is the last question, and I want this question to be your homework so that you can give it a try. I want you guys to give it a try to this question as well. If you are able to solve it, then write the answer of the question in the comment section afterwards. If you are not, still write in the comment section that we were not able to solve it. Start the next mock test with this question, right? So I'm keeping it as such. This is the question which is going to be your homework. I want all of you to give it a try. Yes? Okay. Well, people are asking about my schedule. Well, people, tomorrow on this channel, I won't be taking session, okay? Because tomorrow I've got some family work basically. So I won't be taking any session tomorrow. Yeah? Okay, so tomorrow I won't be taking session. Day after tomorrow, that means on Wednesday. Let me tell you, on Wednesday, I'll start at 9 a.m. in the morning and it's going to be 5+ hour session. It's going to be 5+ hour session. Whatever were the remaining chapters in the last session which I took, that marathon session, those remaining chapters will be done on Wednesday. I'll be starting at 9 a.m. From 9 to 2, we can finish those rest of the chapters, right? Okay, so it was Wednesday, right? Thursday, again, what I'll be doing? Thursday, again, I'll be coming up with mock test. Right? Friday, it's again going to be one more mock test, but the frequency of the question will be increasing. Frequency of the questions will be increasing, okay? Right? So in the today's mock test, I came up with around 30 to 35 questions, right? So questions, number of questions in the coming mock test will be increasing. It can reach to 45, 50 like that per mock test, right? Friday, it's going to be the mock test. And on Saturday, we are going to do a mega mock test. On Saturday, we are going to do the mega mock test in your physics, chemistry as well as mathematics, right? So it's going to be a combined session on Saturday, right? Okay, on Sunday, we are going to have the formula revision. We are going to have formula revision in physics, chemistry as well as mathematics on Sunday. And on Monday, what we are going to have is, we are going to take, if you remember, we took a session, that short session, if you remember, in the last attempt. On Monday, it's going to be the short series, short session, right? 60 short questions. This is the schedule. Yes, this is the schedule which we guys will be following, right? So people, do let me know the answer of this question. And if you're not liked the video, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Yeah, it was nice meeting you. I'll see you guys day after tomorrow. Tomorrow I won't be taking the session, right? Day after tomorrow at the same time. Till then, you take care. Bye bye. God bless you all. Love you all. Keep working hard. Let's kill it together. Bye bye. Take care.